Okay guys, so in this scenario we are going to use a rocket to learn about algebra. So on your screen you can see a rocket, an engine which will force the rocket to go in the up direction. So the first question is it how algebra can be utilized in rocket science. So here we are going to see a very simplified version of the algebra. So let's start it guys. So before we go into the space we need to find certain values. But what is algebra anyway? Let's try to understand it. So we know that 1 plus 1 equals to 2 and 2 plus 3 equals to 5. We can simply add them and find the answer, correct? But suppose there comes a situation where we don't know certain values, because again you know that there are different kinds of rocket and each rocket have different weight. So if we take weight or whatever equation, let's take it x. X simply means that a value which we don't know, and the rocket weight can be write as rocket weight equals to x, the value which we don't know, plus 1. So it's just a formula. So in the place of x you can either write 1, 2 or 3, anything which you want. So if you write x equals to 1, so it will become 1 plus 1, or you can take x equals to 2, which can become 2 plus 1 equals to 3. So by doing this we can simply replace a value and each time the answer will be different. So in the easiest term, algebra is used to find unknown values. Simply put the values in the formula and solve it, and the answer which you will get is going to be your final outcome. Okay, so basically there are two things in the algebra. One is constant. Constant means a value which cannot be changed. In our example of x plus 1, 1 is constant, means in each case, whatever you do, 1 is not going to change. It is going to remain as it is. And the second thing is known as variable. Variable is something which changes. Like in this example we know x is a variable. You can write 1, 2 or 3 or 4, whatever you like, in the place of x. So x is called variable. So the simplest of term, algebra consists of two things, variable and a constant. So in this example we are again seeing a rocket. It's a basic rocket. Okay, so rocket have an engine and it have a body, because engine need to take the body to the space. Now we need to calculate the thrust or the force which is required to take the rocket to the space. But again you know rocket science is extremely extensive science, so here we are taking very simplistic example. So there is one formula. The formula is known as force equals to mass into acceleration. For this video we of course we will not go into the depth part, because again it's a very extensive thing. So we will simply use simple values. So gravity acts on everything, so we need to defeat the gravity also to go into the space. So to find the force, let's take an example. The mass of the rocket. Okay, we can change the mass or we can change the acceleration. By changing these values the amount of force can be changed. But for this example and for this video we are going to change only one thing. Okay, so we are going to keep acceleration as in constant. We will take a simple value of 2500 meter per second square, whereas for the mass we are going to change the value. In this case the mass is something which rocket is throwing out from its engine. Okay, so yeah, so this is the equation. So we can say force equals to mass into acceleration. So here you can see engine is going to create force to move the rocket. 2500 is the acceleration meter per second, 2500 meter per second, it is constant. So let's take an example of mass as 1000 kilogram. Okay, so by changing the design of engine you can change the amount of mass which can be thrown out by the rocket. So the force is approximately, as you can see on the screen, you can simply, for 1000 you know that 1 kilo equals to 1000 gram. So in this case we can simply write force equals to 2500 kilonewton. Okay, so this is the force. Let's test this equation inside the game. Okay, yeah, so in this case what we are going to do is we are going to take three example. and in those three example we are going to change the size of the engine by keeping the acceleration constant in the formula. Okay, so in this case what we have taken is this is the first case, the 1000 kg one. Okay, so here let's see what the force is coming. Yeah, wait a minute. uh okay, sorry. In this case the mass is being taken as 1000 kilogram. Let's see how it will affect the rocket. So as you can see, this is the basic engine design which we have used in our simulator, and the mass of rocket is 1000 kilogram and the acceleration is 2500 meter per second square. So let's see, is this force enough to lift the rocket? Okay, seems like it. The rocket has taken off quite well. The speed is also quite good and it's going upward. So by all the calculations we can see that it was enough. Okay, time for the second case. Just wait for a minute. Okay, so here's the second case. Let's change some of the values. So in the second case we are going to take mass which is thrown out by the engine as 500 kilogram. So when 500 kilograms is being multiplied by 2500, which is the acceleration of the rocket, the amount of force can be find out, which is approximately 1250 kilonewton. Of course it was less than the previous case. So let's see, is it enough? So as you can see, the size of engine is small, isn't it? It's small compared to last case. Let's see, is this thrust enough? Okay, so the rocket has taken off, but as you can see the speed of takeoff is quite less compared to the last case. The rocket is going slowly in the sky. As you can see, the thrust was enough to take rocket from ground to the space or the sky, but it's not good enough for going into the space because the power of thrust is less. In the third case we have just reduced the mass more, just half it, and then you can see the size of engine. So keeping the acceleration same and reducing the value of mass, we can see the case the rocket is not even being able to take off from the ground. As you can see guys, it is not being able to take off from the ground. The engines are fired from their full thrust. The upper thrust of the capsule is also going to full load, but it is not being able to get up from the ground, which is not so good for our case. See, so guys, that's why finding the correct thrust before and takeoff is so important, because as you can see, a simple mistake in the calculation can make this rocket as useless as possible. So we need to find something. Whenever we are doing algebra is basically to help us to find the correct value. So that's why we need algebra. Algebra is nothing but just a basic example of using constants and variables or to find unknown things. So this was one of the real world example which you have seen right now, and yeah, that's for it. Thanks for the class guys. See you afterwards. Thanks, bye.